My name is Brian Dote, and I'm a mobile app developer, and I love helping early stage startups bring their first product to market. I run a local development company called Tapiki, and we build mobile apps, websites, web applications, you name it, for clients both here locally and throughout the United States. Today, we have two exciting speakers, which I'll introduce shortly. Um, First up will be Aaron Ohta. He's the professor of electrical engineering at UH Mānoa, and he has either authored or co-authored over 150 publications in the areas of microelectromechanical systems, microfluidics, and liquid metals for reconfigurable circuits. Amazing stuff. At the halfway mark, we will introduce Dr. Vinod Veedu. He is the Director of Strategic Initiatives at Oceanit, and he is responsible for identifying the strategic direction for the company. He's also the first person I know personally who is in the Guinness Book of World Records. In 2007, he was added for the creation of the smallest nanobrush. He was also selected as one of the 7 innovation ambassadors by the American Association for the Advancement of Science and the Lemelson Foundation. So we're going to start off today's session with Aaron.
So my lab is the Micro Devices and Microfluidics lab at UH Mānoa, and I'm the principal investigator of that lab. So I'll be talking about some of the work that I've done with my team and how that relates to this Hawaii 2.0 theme of this year's festival. So, you know, one of the important things in Hawaii 2.0 is developing technologies and other industries that can help Hawaii, diversify and strengthen. What's important when we get to these really small sizes is that things don't behave as you would normally expect. Because when we're at these larger sizes, you know, like gravity is really important to us. We don't want to fall down because it's going to hurt. But as you make things really small, that becomes much less of a factor. Forces that depend on mass are not as significant anymore. So, you know, that's why like if an ant like falls off a table or something, you know, that's many times its height, but it doesn't really hurt it because there's not a lot of momentum behind that. So going back out to a bigger picture, you know, how can microsystems help with Hawaii 2.0 and even broader than that, some global issues. So these are some global issues identified by the United Nations. One is climate change, one is access to clean water, and of course, health. There's many more issues on the United Nations website, but these are just a few that I'd like to highlight briefly in terms of our microsystems. So for climate change, this is a work from one of my colleagues in the College of Engineering, Professor David Ma. They've been making some small systems where you can generate electricity from having water droplets move around on a surface. And so you can think about, you know, you have a surface, maybe some rain falls on that surface, the rain moves across the surface, that can generate some electricity. It's not raining right now, but it was earlier. So this video that you see here is a water droplet. They're manually shaking it to get the movement, but you can see it lighting up these little LEDs over here. So this is a way to, you know, generate some small amounts of electrical power from naturally occurring events. There's another colleague that I have at the College of Engineering, Professor Sang-Woo Shin, and he is working on some micro devices that address that UN issue of access to clean water. He's developed some very small channels that are able to help with water filtration without using a membrane. So if you've ever used a water filter, you know that after a certain period of time, you got to change the filter because it gets clogged. That's because it pushes water through a membrane. But he's using a different mechanism that uses carbon dioxide to filter water without using a membrane and using much less energy than other types of water filtration. So this is providing potentially providing better access to clean water while also using less energy. The topic that I'll focus on a little bit more is health, because this is the one of the areas that my lab focuses on. So, for example, microsystems can help with health by different kinds of point of care testing. And since Dr. Veedu from Oceanit is talking next, and this is definitely a current event, I wanted to highlight that Oceanit's developing, a COVID-19 test. This is uses some microscale principles in that test. We're also looking at in my lab analyzing single cells. So because a cell is a micro scale thing, we're making systems that can analyze a cell at a time to help improve diagnosing medical conditions and things like that. And we're also looking at ways to move around cells so that we can do things like create artificial tissues and organs, or make things that are like tissues or organs in the lab.
What opportunities are there for our UH students to get involved in research like this?
We have something at the University of Hawaii called the Vertically Integrated Project, or VIP program. This has been something that we've been running since 2015. And the idea here is that there's a lot of research at UH that are organized around real world problems. And that means that we want to create teams to work on these projects that are modeled more on how you would solve a real world problem. So these teams are made out of oftentimes of students of various majors. There's not only one major on one of these teams. They are made out of students from various experience levels. So they're advised by a faculty advisor. There's graduate students that are on these projects working along with undergraduate students from various experience levels. So we have, first semester undergraduate students that have joined these projects, all the way up until undergraduate students that are in their last semester just before they graduate. And they work on these projects over multiple semesters. So by the time they are getting ready to graduate, they have a lot of experience and a lot of knowledge about these projects. They're able to spend that much time on these projects because we've made it so that when they're working on these projects, they get credit for it that counts in the credits they need to graduate. And they would be able to get a more in-depth kind of experience this way.
That's awesome. When you mentioned interdisciplinary teams, is that like across campus in terms of other colleges as well, like marketing or graphic design, or other areas, or is it mostly within the College of Engineering?
Right now, it's mostly in the College of Engineering. We do have students from the College of Natural Sciences involved in these teams, as well as from the Institute of Astronomy. We are working on making it even more broad.
What do you recommend high school students learn while still in high school to prepare them to be successful in the research that you're conducting at UH?
Same thing for high school. It's just having a good fundamentals in math, good understanding of physics and chemistry. Actually, I wish I took chemistry more recently. Last time I do use a lot of chemistry in what I'm working on, but I haven't taken chemistry since high school. So that would, making sure that you have those fundamentals do help.
I'm going to talk about nanocomposite technology that was developed in Hawaii that is making a global impact at this point. The technology is called Hedex, and it is currently being applied globally, pretty much all over the world at this point, for power plants, refineries, desalination plants, and wherever equipment suffer from efficiency, and then also the big challenge around us, the decarbonization. So again, my name is Vinod Veedu, and I'm the Director of Strategic Initiatives at Oceanit. If you want to connect with me, please email me. So I'm going to talk about industrial nanocomposite surface treatments. These are technologies that was developed under Oceanit. If you go and search on YouTube and then look at extreme repelling, water repelling, oil repelling surfaces, you will see 40, 50 different videos, exciting, interesting videos and stuff. But at the end of the day, to make it commercially viable, you need to make them stand all the different pH conditions, the erosions, corrosions, fouling, and all kinds of challenges that you face in particular industry areas. So we call it as industrial nano surface treatments from that standpoint, treatments that can stand these kinds of extreme conditions. So in developing these technologies, we have also addressed the challenges with economical viability of nanomaterials in a broader picture. So I'll share some of those details as we go through this. So then we found, actually in Hawaii, we have a power plant in Hawaii, HECO power plant. As we started talking to them, they said one of their biggest issues in power generation is fouling. Fouling can cause about 2 to 5% efficiency loss in the power plants. So as you see here on the right-hand side, these are actual pictures from some of these plants where you have this big heat exchangers. These are about 30 feet long, 3,000 tubes. And when they get plugged and then erosion, corrosion, leak and stuff, that's a major challenge. It loses efficiency 2 to 5%. 2 to 5% the numbers look pretty small, but the impact is about $20,000 to $30,000 per day in the plant, right? So it's a major impact. To overcome this, additional fuel. Now, what do? So you lose the efficiency, so you burn more fuel. So burn more fuel, what does that mean? So more CO2. So fouling in general is estimated to cost about 0.25% of GDP in reduced production and increased energy consumption. Now, so that's a big challenge there. Now, fouling resistance also causes these equipment to be oversized about 30 to 50%. So that means that in the place of one equipment, you're actually having another dummy equipment just to make sure that the fouling doesn't cause some big issues. So Oceanit developed a material or perfected this technology based on the oil water repelling surface that I mentioned before, which is a water-based material, no volatile organic compound, that we developed a technology called Hedex. So basically Hedex is a combination of materials, application tool, and services all together. The idea is that it is supposed to reduce corrosion, resist fouling, and improve heat transfer, and reduce the CO2 emissions that is related to our power plants or refineries or desalination plants. Two chillers that we addressed in the Hawaii plant. So the left and the right, they have identical shell and tube exchanges. They have the identical number of tubes, about 2,500 tubes. That's along this length. So each one of them, each of these exchanges about 30 feet in length. They take the seawater directly. So what we did was, it actually just a quick video that shows what we did. We went to the plant, built a containment system around these exchanges, and then blasted inside of the IDs of each of these tubes. I've done about like 30, 40 power plants, and again, in all over the world. Just before the COVID, we were on the road like every month. We actually offer a full-scale service, and that's another one. When you're pushing for Hawaii 2.0, it is a Hawaii-grown technology that is actually making an impact in the world. So direct effect on fuel consumption is about 3 to 7%. Immediate deployment possible. We are saying now today. Then actually can also complement the current carbon capture technologies out there. Just a little bit more numbers. So in the carbon capture area, CO2 emissions area, California, the target is by 2030 It's about 4.2 million zero emission cars on the road. That's the objective in California. With new technologies like electric vehicles and hydrogen vehicles and stuff, they're shooting for 20% reduction in CO2 emissions, estimated about 260 million tons of CO2 emission limit. What we are saying is that if CO2, the Hedex is adopted into the power plants, refineries and stuff in California itself, one state, it's about, right now with the Hedex technology, it's about bringing about 1.7 million zero emission vehicles on the road as we speak. It's not looking for the next technology or a decade effort. It's equivalent to about 10% reduction in CO2, 4 to 8 million ton reduction in out of the 98 million ton required. So that's what we're pushing for right now. So in summary, it is a Hawaii-based company. Oceanit developed the technology that has a global impact. And that's what, actually, this is one of my main focus these days here. Hedex saves a significant money to the operator and also brings that powerful story on the balance between efficiency and, or the benefit of efficiency and decarbonization at the same time. As I mentioned before, that we understand the future is renewables, but Hedex cleans up fossil fuels now. Actually, as I'm talking about the Hedex impact in fossil fuels industries, another interesting thing that we're working on in a very powerful country in geothermal area, they have the exact same issues because they have to have a heat transfer done, but it is actually going through the exact same issue. Their heat transfer equipment related challenges are even way more challenging because you're getting all kinds of fluid from downhole that has this extreme behavior. So it has an impact on the existing fossil fuel industries and the potential future as well.
Thank you, Vinod. That was an amazing presentation, and Hedex sounds pretty compelling. You talked about Kahe power plant and some of the other power plants. I believe you mentioned 40 or so. I'm wondering, what are potential uses of Hedex beyond power plants? I can think of, a few that are probably not commercially viable, but where are you headed with this technology beyond the energy arena?
Very interesting question. So I think if you look at, Hawaii, if you look at just a place like Hawaii, you have lots of hotels and every hotel has similar heat exchangers, heat transfer equipment. We know that most of those hotels have, in a hotel, it's interesting because I'll give you an interesting example that I faced in a hotel. Their problems are different from a power plants or refineries. What's the challenge in hotels? If the air condition doesn't work, they get yelled at in the next 5 minutes. It's not like, okay, there is no power, I'm so sorry. They can't say that, like you're paying like a couple of $100 per night or more than that. So you get yelled at. So that is an industry that we are looking at.
What about impacts or uses beyond sort of heat or piping in terms of smart materials or clothing or consumer goods? Any thoughts in that area? We have about a minute or so left.
No, absolutely. So we are working with a couple of the giants in that area, coming up with new materials that would allow you to throw or have a ketchup on your shirt and then just like shake it and then it'll be clean. And so there are things that we're working on beyond a pipeline or equipment or heat transfer surfaces.